Hello everyone, welcome to my channel Mathenthusiasm. Today we're going to look at a crazy problem of integers. What are the last two digits of this huge number? Let's start with a much smaller number, say 1, 2, 3, 4, 5. We can write it as a sum of two integers and express the first one as 123 times 100. Even we change 1, 2, 3 to some other large integers, it does not affect the last two digits. This is shown in the example on the right. The number 100 ensures that those digits are in the front, so we don't have to worry about them. Now, our goal is to write 2033 to the power of 2033 as 100 times n plus x, where n and x are integers, n is positive, and x is between 0 and 99. The value of n is not important, so we just focus on the last two digits, which is x. Well, how do we write it? We change the base 2033 as a sum like this. Now, 2030 plus 3 to the power of 2033 is in the form of a plus b to the power n. So we're going to use Binomial Theorem to expand it. Here, the a terms are in red, the b terms are in green, and the binomial coefficients NCR are in blue. We shall use this color code throughout the whole video. Let's put a equals to 2030, b equals to 3, and n equals to 2033. Then it becomes this complicated form. So how do we use it to get the form 100 times n plus x? Let's look at the red terms in the expansion. They are the powers of 2030. Because the base 2030 is equal to 203 times 10, squaring both sides, we see that there's a factor of 100. Therefore, the terms 2030 squared or higher powers are divisible by 100. They do not affect the last two digits of the result. If you know modulo arithmetic, then this statement can be written in the following way. 2030 squared or higher powers are equal to 0 mod 100. So we can replace all the terms on the first line by 100 times n, where n is an integer. Now we can focus on the remaining two terms. The second one is with 2030 to the power of 1, and the third one does not have 2030. Let's look at the second one. Simplify the blue term first. This is a binomial coefficient. We use the property NCn-1 is equal to NC1, which is equal to n. Therefore, 2033 C 2032 is equal to 2033. Next, for the red term 2030, write it as 203 times 10 again. Therefore, the whole term is simplified like this. Because it's a multiple of 10, therefore the last digit must be 0. In other words, we can ignore the factor 10 for a moment and only consider the last digit of the remaining product. For each integer, only the last digit matters, so we just have to look at 3 times 3 times 3 to the power of 2032, which is equal to 3 to the power of 2034. This leads to an important property of powers of 3. That is, the last digit repeats itself, or we can say that it is periodic. Why is that so? Let's check out the first four powers of 3. The last digits are 3, 9, 7, and 1. As long as the unit digit is 1, multiplying another 3 will go back to the beginning. Therefore, there's a pattern of the last digit. We say that the period is 4. The next step is to check out at which point 3 to the power of 2034 belongs to. Because the power 2034 is equal to the period 4 times 508 plus 2, therefore we only have to care about the remainder 2. Now, the last digit of 3 to the power of 2034 is the same as that of 3 to the power of 2, which is 9. Consider the factor 10 again. That means the last two digits of this huge number are 9 times 10, which is 90. Put this result into the expansion, then the second term can be changed to 100 times n1 plus 90. Again, the integer n1 is not essential. Now, we're left with the last term. In this case, there's no factor of 10 nor 100 to consider. So we really have to check out the last two digits of this green number. Luckily, the last two digits are also periodic. Let's take a look at this table. It shows the last two digits of 3 to the power of n. Indeed, we don't have to find the whole value. Each time, just take the last two digits and multiply by 3. Let's take a closer look at the last box. The last two digits of 3 to the power of 20 are 0, 1. So we can deduce that the last two digits of 3 to the power of 21 is equal to 01 times 3, which is 03. It goes back to the beginning. In other words, the period is 20. Refer to the green number again, because the power 2033 is equal to 20 times 101 plus 13. Therefore, we look at the remainder 13. In the table, check out the 13th term. That means the last two digits of the green number are 2, 3. Then, what's next? Putting everything together, the green number can be written as 100 times n2 plus 23 for some integer n2. Adding up 90 and 23, we get 113. Because it has 3 digits, so let's separate it as 113. Grouping those terms with factor 100 together, then we get the answer. The last two digits of this huge number are 1, 3. How amazing it is to solve this challenging question! If you want to know more interesting problems in number theory, please check out the videos and the playlist shown on the screen and the descriptions below. See you in next video.